KWP, 小攻 Abor. Your learning journey starts now. Ever felt like some math proofs are just black magic? Symbols flying everywhere, rules followed blindly. Well, what if there's a different way, one that actually makes sense? Forget just following the rules. Let's talk about building understanding, step by step. That's the game Professor Duan Yucong is playing with his semantic math. So, how does this semantic thing work? Think of it like climbing a mountain. First, you have raw data, just numbers, facts, like 4, 6, 8. Then, you find patterns in that data. That's information. Maybe you see even numbers can be made by adding two primes. Next level, knowledge. You generalize that pattern into a rule, like the famous Goldbach conjecture. Every even number greater than 2 is the sum of two primes. But wait, why should it be true? That's wisdom, understanding the deep reason, maybe noticing primes go on forever, so they should always be available. And the final peak? Purpose. This is about the ultimate goal, proving that conjecture holds for all evens. It's not just steps, it's a story with a purpose. Let's apply this to the Goldbach conjecture. Remember, it says any even number bigger than 2 is just two prime numbers added together. Using our DIKWP layers, at the data level, we jot down examples: 4 equals 2 plus 2, 6 equals 3 plus 3. Simple stuff. Information layer spots the pattern. Hey, lots of evens seem to be prime pairs. Knowledge layer boldly states the conjecture itself. All evens equal prime plus prime. Now, the clever part, wisdom. Why should this hold? Because primes don't suddenly stop appearing. There are infinitely many primes, giving us building blocks for any size even number. Finally, purpose. We've built a structure that covers all evens, no exceptions. See? A semantic path, not just symbol shuffling. Now for another head scratcher, the Collatz conjecture. Pick any positive integer. If it's odd, multiply by 3 and add 1. If it's even, divide by 2. Repeat. The guess is, you'll always land back at 1. How does semantic math tackle this? Again, DIKWP. Data. Try it with 5, 7, 14. Watch the numbers jump around. Information. Notice the pattern. Odds jump high 3n plus 1, then become even, then get chopped down by division. Knowledge. The process always seems to end at 1. Wisdom. Here's the insight. The jump 3n plus 1 might make it big, but the subsequent divisions slash it down faster. It's an expansion versus contraction dance, and contraction wins. Purpose. Every starting number follows this path to 1. It's about understanding the dynamic tension, not just checking cases. So, why is this semantic approach cool? It's a whole new way of thinking about proof. Instead of just blindly following formal rules like a robot, it starts with meaning. It helps us avoid getting lost in endless case checking, or those proofs that say something exists without telling us how. It connects our gut feeling, our intuition, with rigorous logic. Plus, imagine AI helping us build these semantic arguments, making human-machine teamwork super powerful. It's not replacing old ways, but adding a layer of understanding, making math feel less like cold calculation and more like, well, figuring things out.